Hi everyone, here's a very short tutorial where I will try to explain the relationship between the carbonate alkalinity, the borate alkalinity and the total alkalinity and the relationship to carbon dioxide. Okay, the main rule is this: the total alkalinity is not depending on the carbon dioxide content in the water. If you for instance have a calcium reactor where you have a lot of people at home, so the carbon dioxide in the water will increase and the pH will be down, then the total alkalinity will not change anything. And how does that come? The carbon alkalinity will change. If you for instance increase the carbon dioxide in the water, as I said, by have people at home or maybe the calcium reactor, then the equilibrium will go to the right, so it will be more of the carbonate in the water because you have more carbon dioxide in the water. So the carbonate alkalinity will actually increase with increased carbon dioxide in the water. Okay, but at the same time the hydrogen ions will also increase, and the hydrogen ions will consume the borate alkalinity to the same extent. So the total alkalinity will be the same, because the total alkalinity is the sum of carbonate alkalinity and the borate alkalinity. And that's a good thing we're measuring the total alkalinity, because all devices, the manual test kits, an alkatronic or other KH monitors, always measure the total alkalinity, thus the sum between the carbonate alkalinity and the borate alkalinity. And thus they are not dependent on the carbon dioxide concentration. And that is good, because otherwise, if you only measure the carbon alkalinity, you will have a fluctuation of the carbonate alkalinity together with the carbon dioxide, and that is not what you want, at least not in first place. If you do the opposite, you remove carbon dioxide from the water of some reason, by algae fusion or something like that, then the equilibrium of the carbonates will go to the left and the content of the carbonate alkalinity will decrease. But also the hydrogen ions content will decrease, so the borate alkalinity will increase, because now you will liberate some of the borates to be a contributor to the alkalinity. So again, the sum of carbonate alkalinity and the borate alkalinity will always be the same. The total alkalinity will always be the same when you change the carbon dioxide in the water. And that makes, for instance, alkatronic or as a method very stable, because it will measure always the correct total alkalinity value independently of what you are doing with the carbon dioxide. And this is also a chemical rule, the independence of total alkalinity versus the carbon dioxide. And it's important to know that the total alkalinity consists of carbonate alkalinity and borate alkalinity. And the relationship between these two components, that will vary with the carbon dioxide contents, but the total sum will not vary. Okay, thank you for listening.